In this section, we're going to talk about what causes stalls, how to recognize them, and how to properly perform and recover from them in your flight training. Let's first talk about a few terms that we'll be using to help you better understand the aspects of a stall. The chord or chord line is an imaginary straight line that goes from the leading edge to the trailing edge of an airfoil. Relative wind is the direction of airflow caused by an object moving through the air. For an airplane in flight, relative wind flows parallel and opposite to the direction of flight. So the actual flight path of an airplane determines the direction of the relative wind. The angle of attack is the angle between the chord line and the relative wind. The angle of attack is always based on the flight path, not the ground. The critical angle of attack is the angle at which an airplane will always stall, and is usually achieved at 15 to 20 degrees. The stall is caused by the separation or disruption of smooth airflow over the upper surface of the wing, which causes a rapid decrease in lift. A stall will always occur when the critical angle of attack has been exceeded. This can occur at any altitude, any airspeed, and within any power setting. As you watch the airflow over the wing in straight and level flight, you'll notice that the wind is flowing smoothly over the wing. But as we increase the pitch towards the critical angle of attack, you'll see the wind start to separate from the wing. Once the wing has reached the critical angle of attack, you can see the separation and the burbles that cause the buffet on the wing. At this stage, the wing is no longer generating lift. Therefore, the wing will stall and begin to drop. It is very important that a pilot recognizes the flight conditions that are associated with stalls and knows how to take corrective actions. We will quickly discuss the cues that may help you recognize the formation of a stall. Your vision can help you detect a stall by noting the attitude of the airplane. This can only be used when the stall is caused by an unusual attitude. But in cases where the plane stalls from a normal attitude, vision is of little assistance. Kinesthesia, or the senses of changes in direction or speed of motion, may be one of the most important indicators of a stall. The feeling of pressure is also very important. As the speed decreases, it reduces the resistance to pressure on the controls. The pressure exerted on the controls will become mushy, or lag between the movements, and the response of the airplane becomes less until the controls can be moved with almost no resistance and little or no effect on the airplane. Almost all manufacturers provide a stall warning horn. When the airplane reaches a certain angle of attack, it will cause the horn to sound, indicating a stall is about to occur.
Now that we know how to recognize a stall, we're going to go through the process of practicing a stall. Although stalls can occur at any altitude or any airspeed, studies have shown that they generally happen on takeoffs and landings. A power-on stall is a representation of a stall occurring while taking off. Always make sure when practicing stalls to perform clearing turns in both directions and verify that you are at least 1,500 feet above ground level. For the power-on stall, you want to start the process in coordinated straight and level flight. At this point, locate your heading and altitude. These will be important as you perform the maneuver because you won't want to deviate from your heading. Now that you have chosen a heading and altitude, decrease the power while maintaining altitude in order for the airspeed to decrease. Once the airspeed is decreased to best rate of climb, or VY, you will apply full throttle and pitch the nose up to set the climb attitude while keeping the plane in coordinated flight. At this point, you will no longer be able to apply any more back pressure. During this phase, it will be important that you maintain your heading by the use of rudder control, as the plane will want to rotate to one side or the other. As the airplane reaches critical angle of attack, the stall warning horn will most likely be buzzing and you will feel a vibration or buffeting. Once this occurs, You will immediately lower the nose while maintaining your heading and allow the airplane to gain airspeed without losing altitude.
The FAA has set up a series of standards that must be met during your check ride to pass the specific maneuvers. Here is a list of the completion standards for the power-on stall. Exhibits knowledge of the elements related to power-on stalls. Selects an entry altitude that allows the task to be completed no lower than 1,500 feet AGL. Establishes the takeoff or departure configuration. Sets power to no less than 65% of available power. Transitions smoothly from the approach or landing attitude to a pitch attitude that will induce a stall. Maintains a specified heading plus or minus 10 degrees in straight flight. Maintains a specified angle of bank not to exceed 20 degrees plus or minus 10 degrees in turning flight while inducing the stall. Recognizes and recovers promptly after the stall occurs by simultaneously reducing the angle of attack, increasing power to maximum allowable, and leveling the wings to return to a straight and level flight attitude with a minimum loss of altitude appropriate for the airplane. Retracts the flaps to the recommended setting. Retracts the landing gear, if retractable, after a positive rate of climb is established. Accelerates to VX or VY speed before the final flap retraction. Returns to the altitude, heading, and airspeed specified by the examiner.
Start out in straight and level coordinated flight. You'll want to choose a heading and altitude that is at least 200 feet below your current altitude to simulate an approach to land. During the stall, you will not want to descend below this altitude. Now pull the throttle back to normal approach. Hold the airplane level until the airspeed decreases to recommended approach speed. Once approach speed is achieved, lower the nose and set the power and attitude until you are in a stabilized approach. Maintain this pitch until you reach your designated altitude. Smoothly start to pitch the nose up to maintain altitude. Your directional control will be maintained with the yoke and rudder inputs. Hold the airplane until you hear the stall warning horn. As the stall develops, you will feel the vibration or the buffet on the wings. Once you feel a buffet, the pilot should immediately start the recovery process. This is done by applying full throttle and decreasing the pitch by allowing the nose to drop. Try to hold this altitude so that the plane can gain airspeed and achieve a positive rate of climb. At this point, you will want to retract the flaps and gear if applicable, or as they say, clean up the plane.
The FAA has set up a series of standards that must be met during your check ride to pass the specific maneuvers. Here is a list of the completion standards for the power-off stall. Exhibits knowledge of the elements related to power-off stalls. Selects an entry altitude that allows the task to be completed no lower than 1,500 feet AGL. Establishes a stabilized descent in the approach or landing configuration as specified by the examiner. Transitions smoothly from the approach or landing attitude to a pitch attitude that will induce a stall. Maintains a specified heading plus or minus 10 degrees in straight flight. Maintains a specified angle of bank not to exceed 20 degrees plus or minus 10 degrees in turning flight while inducing the stall. Recognizes and recovers promptly after the stall occurs by simultaneously reducing the angle of attack, increasing power to maximum allowable, and leveling the wings to return to a straight and level flight attitude with a minimum loss of altitude appropriate for the airplane. Retracts the flaps to the recommended setting. Retracts the landing gear, if retractable, after a positive rate of climb is established. Accelerates to VX or VY speed before the final flap retraction. Returns to the altitude, heading, and airspeed specified by the examiner.
A secondary stall can occur after recovering from a preceding stall. This is caused by attempting to rapidly recover from a stall before the airplane has regained sufficient airspeed to maintain flight. When this occurs, the pilot should release back pressure on the yoke, allowing the nose to pitch down as with the normal stall recovery. After the airplane has achieved sufficient airspeed, it can be returned to normal, straight, and level flight. The stall usually occurs when the pilot uses abrupt input to return to straight and level flight. With smooth control of the airplane, the secondary stall can be avoided altogether.